So in this video, we are going to look at simultaneous equations by the method of substitution. So the substitution method. This color isn't suitable. Let me pick a more brighter color. So same sets of simultaneous equation to keep it consistent to show all the methods. Two x plus y is equals to 1. So call this equation 1, call this equation 2. So the first step in the substitution method, you can either pick equation 1 or 2. It's up to the choice of the student, and make either x or y the subject of the formula. So I would pick equation 2 and make y the subject. So from equation 2, y would be 1 minus 2x. Call this equation 3. Now, from the equation, you have chosen and making whatever variable, be it the y or the x. You need to take this equation 3 and substitute it into the equation 1, or the initially unchosen equation. So sub 3 into 1. We will end up with 3x minus 6. Wherever we see y, we put equation 3, 1 minus 2x equals 24. So 3x minus, expanding, minus 6 by 1 is minus 6. Minus 6 by minus 2 is positive 12x equals 24. Now, taking this work into the top here, simplifying, 3 plus 12x is 15x. Carrying across is 6, we would get 24 plus 6, which is 30. So this would imply x is 30 all over 15, which is 2. So now that we have gotten the value of one of our variable, from our equation 3, we can plug in the obtained value and simply get our another variable. So from 3, we have y is equals to 1 minus 2 by 2, which is 1 minus 4, which is minus 3. So exactly what we got. Let's test it again. So from equation 1, to see if our answers are correct. So the test, pick any equation, but I just pick an equation. Now I'll pick equation 2. So 2 by 2 plus minus 3 should give 1. So 4 plus minus 3 is minus 3 equals 1. So 1 equals 1. So therefore our solutions are correct. Now, an interesting thing to discuss here. Any pair of simultaneous equations you are given, if you look carefully, these are actually the equations of lines. Now, we are finished with the method of substitution. This works for all simultaneous equations, because certain simultaneous equations, when the coefficients are fractions, it makes things very difficult to use the elimination method. That's why my go-to is the substitution method. The substitution method. So notice equation 1 is actually 3x minus 24 equals 6y, which would imply that y is equals to 3x minus 24 all over 6, which is y is equals to 3x all over 6 minus 24 all over 6. And this simplifies to 1/2 x, 6 into 24, 4 sixes minus 4. So we can see this is actually the equation of a line with gradient. M is 1/2 and y-intercept C is -4. And similarly, with equation 2, we will have gotten y is equals to minus 2x plus 1. Gradient M is equals to minus 2, y-intercept is 1. So when we solve simultaneous equations, what we are actually getting is the points on the Cartesian plane. Let me just try to sketch these lines here. So line 1 would be the y-intercept is minus 4, so something here. It's not drawn accurate, but just to show something. And this one is this here is actually minus 2. So the gradient, and here is 1, something like that. And here it's not drawn to scale, but this is just an interpretation of what we are actually doing. X-axis here. Here would be the points of intersection of the line. 2 and minus 3 respectively. See, because I didn't draw it to scale, the minus 3 on the y-axis, so it's supposed to be more down. This is not drawn to scale, but it's just to illustrate that simultaneous equations are actually, you're finding the intersection of two lines graphically. So that's it for this video. If you enjoyed, please like and subscribe.